Hey, welcome back everyone. Now, before I jump directly to the concept, let me ask you something. Have you ever tried to connect more than 5 or 6 VPC together using just VPC pairing? Maybe you had a dev VPC, prod VPC, test VPC, and a data VPC, and you try to wire them all up with pairing connection. If you have already tried, so you know the nightmare. For VPC means you need 6 pairing connection. That's fine, but if you have 10 VPC, you are looking for the 45 connection, and it get messy. If 50 VPC, that's 1225 pairing connection. You need to manage, monitor, and troubleshoot. And the worst part, VPC pairing is non-transitive. Means if you have VPC A, VPC B, and VPC C, and you create the connection between VPC A and VPC B using pairing connection, and same for the VPC B and VPC C. But C cannot communicate with the VPC A via non-transitive way. So you need to create the separate connection between the A and C. That's exactly the problem AWS Transit Gateway solve. And today we are going to do complete deep dive from the fundamental all the way to the real world enterprise pattern. So we will cover everything. Let's get started. So the problem, full mesh VPC pairing doesn't scale. 4 VPC need 6 pairing connection, 10 VPC need 45, and 50 need 1225 connection. Non-transitive routing, no centralized control, management is nightmare. In case of transitive gateway, we have n number of VPC, always need an attachment. One central routing hub. Full transitive routing, route table per attachment. Centralized policy control. Scale to 5000 plus VPC. So next is AWS Transit Gateway. It's a regional, highly available network transit hub that lets you interconnect your VPC on-premises network and other AWS services, also in a single gateway. Think of it like a router in the cloud, or even better, think of it like a hub of wheel. Every VPC, every on-prem connection, every VPN, they are all speaks that connect to the central hub, and traffic can flow between any two spokes through the hub without needing a direct connection between them. That's what transit routing means. The traffic goes spoke A hub, then to spoke B, and you control exactly which spoke can reach which other spoke using route table. Now there are 4 characteristics. First one is hub and spoke model. This is the core architecture. Instead of a mesh, you have a star topology. Everything connect to a transit gateway, and the transit gateway route traffic between them. Much simpler to manage and reason about. Second one is full routing control. Transit gateway has its own route table, completely separate from your VPC route table. You can create multiple target gateway route table to segment traffic. We will go deep on this in a few minutes. Third one is multi-region support. You can peer transit gateway across AWS region. So if you have VPC in US East 1 and you want to connect into AP South 1, you can connect their respective transit gateway and route traffic globally with low latency over the AWS backbone. Fourth one is security and segment. By using separate route table per attachment, you can completely isolate environment. Dev can't reach prod, prod can't reach dev, but both can reach shared VPC or shared services, and you control all the centrally from one place. Next one is key component deep dive. So component 1, transit gateway itself. So transit gateway is actually hub resource you create in AWS. It's a regional, so one transit gateway per region. Typically, it's highly available. AWS manage the underlying infrastructure across multiple availability zone automatically, and it can support up to 5000 VPC attachment. Component 2, attachment. An attachment is how you connect something to the transit gateway. Think of it like a plug that connect resource into the hub. We have a VPC attachment, VPN attachment, direct connect hub, etc. Next one is route table. This is where the magic happen, and this is the part most people get confused about, so pay attention. Transit gateway has its own route table, completely separate from your VPC route table. By default, when you create a transit gateway, it creates one default route table. Every attachment gets associated with this default route table, and every attachment CIDR get propagated into it. That means by default every VPC can reach every other VPC, full connectivity. Next one is association. Each attachment must be associated with exactly one route table. This association determine which route table is used to make routing decision for the traffic coming from the attachment. Think of it the way when a packet arrive at the transit gateway from a VPC, the transit gateway look at which route table that attachment is associated with. Next one is propagation. Propagation are how a route table learn about the CIDR of a attachment automatically. When you enable propagation for an attachment into a route table, the transit gateway automatically inject the attachment CIDR block as a route in that traffic route table. So traffic destined for that CIDR will be forwarded to the attachment. Next one is hub and spoke architecture. So you can see I have created the multiple dev VPC, shared service VPC, on-prem direct connect, and the other VPC as well. So your development environment is for the dev VPC, for production environment is for the prod VPC. Shared VPC is for the think like DNS or other services which you want to do some monitoring or the patch management on-prem or via direct connect. So you are centralized via the direct connection gateway. We have a spoke VPC which is for the another workload. Then we have a VPN, a site-to-site VPN for a remote office or a branch. Each of these connect with the transit gateway via an attachment. And for the transit gateway perspective, it doesn't matter if a spoke is a VPC or on a on-prem connection. They are all just attachment with the CIDR. So next is route table, the core of segment. First one is association, one per attachment. It is one to one. Each attachment mapped to exactly one route table. Say you have a prod VPC attachment to the target gateway. That prod attachment gets associated with the prod route table and only prod route table. You cannot associate it with two route table. One attachment, one route table, hard rule. Second one is determine which route table traffic from that attachment. So when a packet leaves your prod VPC and hits the target gateway, the target gateway check which route table in prod's attachment associate with it. Answer prod route table. Now it looks up the destination IP in prod route table and decide where to send it. That's the route table doing the routing from the attachment. Third one is this attachment uses this route table to make routing decision. Think of like GPS. The prod attachment picks up prod route table as its GPS map. Whatever routes are in that map, those are only destination prod can reach. If a route isn't it prod route table, prod can't get there, period. Next one is propagation. So it is one to n relationship. An attachment can propagate CIDR into multiple route table. What does that mean? Same prod, let's you have a VPC and has some CIDR 10.2.0/16. You enable propagation from the prod attachment into shared route table and security route table. Now both these route table automatically have a route for the that VPC which has the CIDR 10.2.0/16 pointing to the prod attachment. One attachment injected its CIDR into two different route table. So this is the propagation. Second one is auto inject the attachment CIDR as a route. You don't manually add the route. The moment you enable propagation, it was automatically route for that VPC which has the CIDR, let's suppose 10.2.0/16 prod attachment into the target group route table. No static route, no manual entry, it's dynamic. If the CIDR changes, the propagation update automatically. Next, let this route table know the CIDR. Now for the example, you have a shared service VPC propagation. Its CIDR 10.3.0.0/16 like previous one has the 10.2.0.0/16 into both dev and prod route table. So dev knows how to reach shared service and prod knows how to reach shared service, but dev doesn't propagate into prod route table and prod doesn't propagate to the dev route table. So they are invisible to each other. Real world tip, I have given the tip over here. The last point is the real world pattern. Dev VPC, prod VPC, shared VPC. So we have a different VPC. To prevent, we have to separate the route table. Both can reach DNS and TP monitoring, neither can each other database services. Real world at the bottom. The last point is the real world pattern. Dev VPC, prod VPC, shared VPC. Three separate route table. Dev and prod only see shared service in their route table, not each other. Like we have set up some resources into the VPC and some setup in the prod. And we have a shared VPC where our logging is enabled monitoring. Dev knows the shared service, prod knows the shared service, but dev and prod don't know about each other, so they are invisible for each other. Okay, next one is attachment type. So first one is VPC. Attach or VPC required subnet per availability zone in the VPC. Support up to 5000 per target gateway. After that we have a VPN. VPN is a site-to-site VPN connection. Support ECMP for bandwidth aggregation up to 50 GB. It is basically site-to-site IPsec, way better than a VGW. Next one is direct connect. 1DX gateway attachment. All your VPC can reach on-prem, no VGW per VPC needed. Next is target gateway pairing. Pair target gateway across region for a global low latency inter-region connectivity. Last one is connect, that is WAN. Integrate via GRE tunnel. BGP supported up to 5 GB per attachment. That's it. So next slide is transit gateway versus VPC pairing. When to use what? It is the most comparing services in the networking section in AWS, and it is mostly asked interview as well. So first one is routing. Pairing is non-transitive, transit gateway is fully transitive. That's the biggest difference. Next one is scale. It has the limited, you have to create the mass, which is explode as well. So I have written mass explosion. It has up to 5000 VPC. Target gateway is always attachment for n VPC. Pairing connection explode as you scale. Next is cross region. Both are available for the cross region. Next one is on-prem connectivity. It has no directly connectivity on the on-prem. Meanwhile, transit gateway we have a VPN and the DX gateway for the connectivity. Next, bandwidth, no limit for the VPC pairing for the inter VPC, and it has the limit up to 50 GB PS per AZ. Next one is cost. If you go for the cost, pairing is cheaper for 2 for VPC with low traffic. You only pay per GB. Transit gateway adds 0.05 R per attachment on top of data charges. Next is complexity. So it is simple one-to-one. It is more config upfront in case of transit gateway. Best for simple, low scale and cost sensitive. And transit gateway is best for enterprise and the multi account. You can set up the transit gateway even in the hybrid account as well. Okay, next is multi account strategy with RAM sharing. RAM is for resource access manager. Okay, I have given the definition. AWS resource access manager is allow you to share a target gateway created in a network / transit account with member account across your AWS organization without VPC pairing. Like in case of enterprise pattern, one transit gateway shared across your whole AWS organization. Create the transit gateway in a dedicated network account, then use AWS RAM resource access manager to share it with every account like dev account, prod account, security account. They all accept the RAM share, then attach their own VPC directly. Each account manages their own attachment. The network account manages the transit gateway and route table. So it has the clean separation, central account. This is exactly how AWS landing zone and control tower set this up. One note I have given that transit gateway must be in the same region as the VPC being attached. Even for cross account, use transit gateway pairing for cross account. So I have given the diagram as well. Transit gateway with the network account you can set up with the dev, prod, share. Basically you have the organization, so you can set up it. And for the RAM sharing, we have a network account share, transit gateway, all member account accept the share. Each attach their own VPC directly to the transit gateway. From their account, one transit gateway, many account. So this is the basic multi-account strategy. It is used in the enterprise level. I will not show you into the demo, I think, but I'll show you the demo that how transit gateway work. Next one is pricing and service limit. So pricing, if we can say for the US East one, per attachment or per hour, it is 0.05, which I have explained already. And it is also separately charged VPC, VPN, DX. It also charged per hour. Per GB process, it's also charging like 0.02 per GB. All data, either it's go in or out. Next way is transit gateway pairing attach. That is $0.05 per hour. And plus you have to pay the price data transfer, that is 0.02 G per data. Key service limit VPC attachment per transit gateway is 5000. Route table is 20 you got the default this value, you can increase into the support request. Next one is route table. It is the 10,000 limit. BGP prefix, you can attach the 1000 per attachment. Next one is bandwidth per AZ. It has 50 GB busting. Next one is transit gateway per transit gateway. It has the 10. So these are the pricing and the service limit. Okay, next one is real world use cases. First one is centralized egress. That means one NAT gateway in an egress VPC instead of one per VPC. Saves a ton of money at scale. Second one is centralized inspection. So route all east-west traffic through a security VPC running network firewall or Palo Alto. Full visibility, one place. Third one is shared services like DNS, NTP, AD, PAS servers in one VPC. All account reach it via propagation. No pairing needed. Fourth one is hybrid cloud. All DX and VPN connection terminate at one transit gateway. One BGP table rule them all. Fifth one is multi-region DR. Peer transit gateway across region. Failover by updating propagation. Fast and clean. Last one is dev and prod isolation. Separate route table. Zero accidental. Cross environment traffic. Sleep better at night. Okay, quick recap. So first one is transit gateway, that is transitive hub and spoke. Pairing can't do this. A route table plus association plus propagation. Master these three, you can build anything. Next one is RAM sharing. One transit gateway, whole organization, network account owns it, everyone else attaches. Next one is segment without firewall, just route table. Next is cost. Cost means attachment plus data. Keep attachment lean. Next one is transit gateway pairing. Global networking on AWS backbone. That's it for transit gateway. If it helped, smash the like, subscribe to PythonDevOps. Next up, we will do the demo. Thank you.